So, how to get started here. So we left off last Thursday. I'm thinking about nonlinear regression, but not in the context of a single variable. We start to interact variables. Okay? We're going to kind of pick up where we left off, really just getting more examples of a lot of the stuff we talked about last Thursday, but kind of dive a little bit deeper. Okay. I saw some of you last week kind of stop by to kind of look over this exam score. Everything should be kind of currently up to date on Canvas. If you have any questions, as always, I tell all my students, like, sooner you let me know, the easier it is to kind of deal with things, right? So I just had someone ask me their quiz was submitted right at the minute, and so it was showing up as late, even though the late in time showed was 0 minutes, right? So if you ever notice anything, you have a question on it, please reach out to me as soon as possible so we can kind of get things settled if there's any kind of discrepancies that you think exist. Otherwise, I did add one thing to kind of this thing that wasn't up there before, which was this election data, which we might use today. I think we'll have time. If not, we'll probably use it on Thursday. So this do file, and then kind of PowerPoint slides kind of that we're working with last Thursday. That's where we're going to start. So unless there's any other questions for me, we'll probably just kind of dive right into it here today. Okay, so we're talking about last class, kind of differences in slope. And the kind of setup we had was you're interacting a dummy variable with a continuous variable. So you said, if that's the case, there's different marginal effects for these different groups. So this was kind of the idea. If I run this regression where I include both female and this looks variable, but also the interaction of the two, that's going to provide a different marginal effect, right, of this beauty variable looks, right, for both males and females, right? So we kind of then talked about there's some additional kind of research out there that looked, instead of like wages, they had interview requests. We kind of had something that looks like this, which is maybe showing that the marginal effect of this attractiveness variable or this looks variable, the slope is much flatter for males than it is for females, right? So what we were doing there, just kind of as a review, and we'll use that example that we were looking at last class. And here I'll just think of wages instead of log wages just to make it a little bit easier. And we'll kind of ignore the other control variables just for the sake of kind of getting at looks variable, right? Or this beauty variable. So here we had the interaction of the two. So what we focused on last class was thinking about what is the marginal effect, what is the marginal effect of this looks variable? Or essentially, when we say marginal effect, we're looking at this line of best fit. So it's what is the change in our y variable coming from a change in whatever we're trying to find the marginal effect of. We said to find a marginal effect, if I want to know the change in my total cost divided by a change in quantity, I would take a derivative, right? So if I ever have an equation y as a function of x, how do I find the slope or the marginal effect? I take a derivative y in respect to x. So here, our marginal effect looks a little bit different for both groups. So if we're thinking about kind of the male group, when I take a derivative of this function in respect to looks, right, the thing that's changing, what am I left with? Beta 2 plus beta 3 times female. Well, for males, this female dummy variable will be equal to 0. 0 times anything. Essentially, just the coefficient on that linear term for looks is the marginal effect for males. Now for females, I take a derivative, it's the exact same thing, but now my dummy variable is equal to a 1. So the 1 relative to the 0 group, this marginal effect has this additional component. So when we're thinking about kind of that visualization, if I'm thinking about this looks variable and its impact on wages, that line of best fit for males, if my line of best fit for females looks like this, what must the sign of beta 3 be? Yeah, right? Here, marginal effect or the slope of that line of best fit for males is beta 2, whereas for females it's beta 2 plus beta 3. So if it's steeper, beta 3 must be positive. Now I'll draw out a different example for you, and then we'll kind of come back to this, but just to kind of give you, this isn't always going to be the exact same thing. Okay. So let's say I had a different, I don't even know what the two variables would be, but let's say I'm looking at the effect of my y variable, effect of my x variable on my y variable. And let's say I see something that looks like, I'll do two different examples. So let's say here's kind of my zero group's line of best fit, or in our example, this would be beta 2. And let's say that for the one group, I know that marginal effect is beta 2 plus beta 3. So in this example, what must be true about beta 3? If the slope is flatter, beta 3 must be what? Negative. Right? Now, in both cases, I have upward sloping lines, so beta 2 is what? Positive. So I could have a really weird example, right? Not really weird. This actually probably could take place, right? Where if I have a continuous x variable I'm trying to calculate the marginal effect for, what if I had my zero group? So I know that the effect for them is just beta 2. Well, here beta 2 would be what? A negative. What if here the estimated kind of line of best fit for group 1? We know that that would be beta 2 plus beta 3. So what must be true about beta 3?
Positive and bigger than the negative effect of B2.
Not only is it positive, but in order for the total effect to be positive, you're correct. Beta 2 would actually have to be less than beta 3 in absolute value, right? There would have to be that it would kind of cancels out the effect of just that linear term when we're looking at the interaction term with that dummy variable. So we have all kinds of combinations of these things, and we can kind of, I think, drawing out the visualization sometimes kind of helps us see like what the sign of these coefficients, what that's actually telling us. In this example, if we had this be the case, I think, let's think of one where, what would something be that creates this? So there's a negative effect. Maybe there's something like you interact age with wages. And I don't know, maybe the dummy variable is a certain degree type, like maybe, I don't know, not to pick on them, but like a foreign language, right? Well, then as I get older, right, the effect of my age, I'm probably going to see that maybe, typically, I would think I probably have the reverse where like maybe my wages go up, but potentially if I have this skill that is becoming not as valued by the market over time, then maybe I get a complete flip in the sign of what the effect of kind of my age is. As the older I get, I would expect to see higher wages. If I have a degree type that is less valued by the market, maybe then I see negative wage. So there my group 1 and 0 will be flipped. But you can imagine there could be some scenario where these signs of the total slopes for these groups are different. Is that any questions on that idea? So that's kind of where we left off. Well, we can push these interaction terms one step further, okay? And this, I don't believe we spent time on. So here I was looking for the marginal effect of looks, right? Let's say I had the same regression equation, but I want to know the marginal effect of being female here, on wage. That would be the change in my wage coming from a change in this dummy variable female. What would that marginal effect be? Well, if I take a derivative of this in respect to female, I now have beta 1 plus what? Beta 3 times this looks variable. So here, the marginal effect of female So just like before, the marginal effect of looks depended on what it was interacted with, right? The marginal effect was different for males versus females. It was interacted with that female variable. The marginal effect of being female will vary with the variable that it was interacted with, this looks variable. So here, if I had kind of beta 1 plus beta 3 times looks, I think if we go back to the regression results, right? I think looks, so we've got what? 0.039, and then female was negative 0.53. So negative 0.53 and 0.039 were the values we were looking at. So this was negative 0.53. This was 0.0, we'll just say 0.04 to make it a little bit easier there, okay? So notice what's true about the marginal effect for being female. When looks is 0, the marginal effect would definitely be what? Negative. But at some point, if this continues to increase, what could happen to the marginal effect of being female on wages? Well, as this variable goes up, I would be adding a larger and larger positive value. So there's a point here. There could be a looks rating in this example, right? A beauty ranking, if we were doing this percentiles or whatever it is, that would represent a turning point, just like we had for those quadratic relationships. So essentially what are we saying is, where does the effect of being female kind of switch, right? If we ever have a sign on that dummy variable that is different than the sign of our interaction term, we know there's going to be a turning point that exists. If these were both negative, where would the turning point be? So let's assume. So first let's figure out where the turning point is, and then I'll throw this hypothetical at it, right? So essentially what I want to find out is, where is this marginal effect equal to 0? So I would set it kind of equal to 0, and I know that marginal effect is negative 0.53 plus 0.04 times looks. It's just a little bit of algebra here. I get what? 0.53 divided by 0.04. This look, whatever value that is, that would be the looks rating that switches this turning point. Okay. So in this example, I don't know, this is going to be what? Something over 10, 11, 12, about, if I'm looking at this correctly, approximately 13, right? I'm just doing some very rough, terrible math in my head here, but about 13, right? Well, I think in the example, if I go back, I think the looks variable only went from 0 to 10. Okay. So if that looks variable, the only possible values I could see goes from 0 to 10, this turning point would never exist, right? And in fact, if that's where it switches from being negative to positive, I would say that there is no turning point. Right? So I think there's a question like this on the problem set. And I'm not saying that it is a point that doesn't exist, but once you find that turning point, the next step is I need to figure out, is that something I could even see in the data, right? And in this case, it would be a value that's so high, I would never actually see that that marginal effect becomes positive. Now, if this variable was instead a measure of attractiveness as a percentile, and it went from 0 to 100, well, then would that turning point exist? Yes. In fact, most of those looks values in that scenario would actually be positive. So I can solve for this turning point, and really what this ends up being, remember, what do these values represent? This was going to be the coefficient of my dummy variable divided by the coefficient of my interaction variable, right? And that's always what it'll be. Okay. Now, if these are the same sign, so let's assume in this case, let's say I had negative 5.3 and negative 0.04. Well, and I'm sorry, what I leave out here? If the coefficient is negative, when I do that algebra, right, I had to subtract this, right, which essentially here, since it was already negative, I had to add it. So if they're the same sign, I would always end up with a negative value here. Well, for this variable, would a negative turning point, ever exist? Well, if it starts out at 0, if they're both negative, then the turning point is negative, it would never exist, right? And this might be true for other things, like maybe I'm trying to predict, I don't know, infant deaths using the GDP of a country, right? And maybe I interact GDP of a country with whether or not it's a developed versus a non-developed nation. Well, if that turning point was ever negative, can I ever see GDP actually be negative? No, right? So sometimes, even though we can always find where this turning point is, often it might not make sense in the context of our data. And really that's just looking at that turning point. And then how would I kind of see if that makes sense using my data? Well, remember, this is the turning point of the looks variable. So how could I do that in Stata? Just simply sum looks and look at what the minimum maximum values are. And if that turning point is anywhere outside that range, I'll never see that turning point exist. Now, if the turning point is in that range, well, then I will see this marginal effect go from being positive to negative. Okay. And we'll look at some examples here in Stata later today, kind of where we do a similar thing. Okay. So we didn't really look at this last class. We were kind of focusing on the marginal effect varying between the two groups. Okay. Any questions on this thing here before we keep moving? Yeah. This is where I'm getting paranoid. Okay, I did hit start. All right. So go back here. So we kind of already talked through this, but right, really, and I think if I took it out to the third decimal, whatever I kind of find from this regression, I think here I had slightly different. Oh, maybe I probably plugged this value in, right? This was 0.0. We were using 0.04, which put that approximately at 13 based off of kind of what we were doing off the slides. Okay. So I'm going to take this. We'll now kind of go back to a data set we were looking at in Stata. So I think what I want to focus on here. Oh, we'll do this one again. So we'll use that MBA shots data. So I've got it open, but I'm just going to rerun just to kind of show you what you would do in practice. So I get my global path set correct. I'm going to have that MBA shot data. So I'm going to open that up. I'm going to create these center and tall variables. I'm then going to go down here. So I've got some old code here. I'm going to show you how I would do this. So I'm going to copy and paste that real quick. And we're going to use this interaction of all with shot distance, right? And I then throw in a bunch of additional controls. So that's probably the one that we're going to want to focus on, right? So we can get rid of this because we know that this is a better regression because we have a bunch of omitted variables that we've included, okay? Now, instead of using kind of the shorthand built-in syntax that I have in Stata, which is I can take the dummy variable, double pound sign or hashtag with that continuous variable, it just gets a little bit tricky if I want to use those coefficients after I run the regression, all right? So we said, and I think I had an example up here where I said, if I want to start to use these, maybe creating the variable, the interaction term myself might be a little bit easier. So we're going to do that here. And I'm going to call this tall shot distance, right? Now, if you want, you could kind of spell this out even more. I'm just going to kind of shorthand it here. And this is just going to be the interaction of tall with that continuous variable of shot distance. Okay. So instead, in my regression, I'm not going to use the shorthand. I need to make sure I include my dummy variable, my continuous variable, and then also the interaction that I created between the two, right? So I now kind of have this interaction term that I've created. I'm going to run this regression, okay? So I go ahead, run this regression. I now have the coefficient on the dummy variable, the continuous variable, and the interaction between the two. Okay? Now, these start to get kind of small, 0.00208. If I start to just do like some rough, math in my head, I might actually be doing some egregious rounding and come with some very different values. So I want to be very precise. I can do that in Stata, right? So here, we'll go back to kind of what we did last class. If I want to know the marginal effect of shot distance, right? That's the continuous variable. It might vary between the 1 and the 0 group. So here my 1 and 0 group was just, did I identify this player as tall or not? Right? So if I'm thinking about someone who's not identified as being tall here, what would that marginal effect be? Well, that's simply the coefficient on that continuous variable, right? Because when I take a derivative of this in respect to that continuous variable, I'd be left with beta 3, the interaction term coefficient, times kind of that tall variable. If the tall variable is 0, 0 times anything is 0. So that's where when we're just looking at the marginal effect of the continuous variable, we're going to have two marginal effects. So if it helps to kind of think about that, the marginal effect of your continuous variable, you're going to have two marginal effects. One for the 0 group, right? But we're also going to have the marginal effect for the 1 group or tall players here. Well, what will the marginal effect be for them? It's still going to be that coefficient on the continuous variable, but we're also going to add in now that coefficient of the interaction term, right? Because now when we take a derivative, so this is where we can kind of compare this to what we were doing before. So I'll save this for a second. If it helps, write this out every time you're looking at a regression. So I was kind of looking at, now I forget, was this just whether or not the shot was made? Yeah, so was the shot made? And we had this dummy variable, this continuous variable, then the interaction of the two. So if I wanted the marginal effect of shot distance, right, or my 0 group, or the group that wasn't identified as tall, that was simply going to be equal to beta 2. Or for the 1 group, if I took a derivative of this in respect to shot distance, I would have beta 2 plus beta 3 times tall, but the tall variable would be equal to 1. So I'd have the coefficient on the continuous variable plus the coefficient on the interaction term. Okay. So when I'm doing this in Stata, all I have to do is now add in, oops, if I can type correctly, that coefficient on my interaction term as well. Now, this is where you can do it using the other method, where I've used the built-in code that creates the interaction. It doesn't actually create the variable, it just creates it to run in the regression. But now I have to like type all £, C dot shot distance. It's easy to forget I need a C dot. I might accidentally use double £, or it's just maybe a little bit trickier. I just always think creating the variable yourself, you now know what that interaction term variable is called. So when you're trying to use its coefficient, it's a little bit easier to kind of type this out. But it's all personal preference at the end of the day. Like, you know, they say coding is like, well, since you guys are getting like a mild form of coding, right? It's basically like, we might all talk English, but my English is probably a lot different than some of yours, right? It's probably much worse than a lot of yours. So, you know, when you're coding, right, there's different ways to do the same thing, and we all kind of have our own vernacular. We all kind of have our own regional dialects, if you will, right? This is my dialect. I like to create the variable as long as the data set's not too big, because it's just easier to then use those coefficients. Okay. Any questions on this idea? And so then if I've already run the regression, when I run these display commands, they essentially would just tell me, and this is where if I've added in kind of comments, it kind of reminds me, oh, whoops, except for I didn't select the comment here. So let's select all of this. Okay, here's the marginal effect for the non-tall group. And here's the marginal effect for the tall group. It's a little bit smaller. So what must have been true about the coefficient on the interaction term here? If it was a smaller negative value, if I'm looking at this correct, then the interaction coefficient must have been So if it was negative,
Positive.
when I added in, it would be an even larger negative value. So here it must have been positive, about what? 0.002-ish. Sure enough, I go back. Oh, 0.002. Any questions on anything there? Can we see this okay, by the way? If this is zoomed in enough? Okay. If you have any questions at any point, kind of slow me down. Now, the thing that we introduced today is I can also find the marginal effect of that dummy variable, right? Or that one group, right? So we said, what is that going to be? Well, very similar to what we were doing with our wages, kind of not continuous variable of looks, but we were looking at the marginal effect of being female. So if I want the marginal effect here of belonging to that one group or being tall, now the derivative of this equation would be what? Beta 1 plus beta 3 times shot distance. Okay. So my marginal effect will be, I can't just calculate 1. You would actually have to tell me what shot distance do you want to calculate the marginal effect of, right? So if I go back here, I know that my marginal effect of being tall will be the coefficient on that tall variable, but also plus the coefficient on the interaction term multiplied by whatever the value of that continuous variable is. So if I try to do this, it's not going to tell me anything because, well, actually, this is where I'm testing my state of knowledge because you usually wouldn't do this. I don't think this will run. It might do something really wild. Yeah, so I think what it does is uses the average shot distance. I can't remember what it defaults to here, but essentially if I want to know the marginal effect depends on what that shot distance is. So I would have to, in the problem set or on a quiz, ask you, even if I gave you the regression output, what's the marginal effect for a tall player taking a shot from, I don't know, 20 feet from the basket, right? And in fact, I think this might be measured weird, so we'll just look at, it's like this ranges from 1 to 86. So I think this must be feet. 86 must be about the length of a basketball court. So I would actually have to tell you kind of what is the marginal effect, or ask you, sorry, for the marginal effect of being tall on whether or not the shot is made from 20 feet away. I could do the same thing. Copy this. What's the marginal effect if it was, I don't know, 32.35 or 2345 feet away? Right? All you would do there is you're using that same exact kind of line of code. But now I'm asking you for that specific marginal effect at 20 feet and at 32.2345, right? Now when I run this code, I can find the marginal effect of being tall for any shot distance. Now notice here, I luckily chose two values where what could be true about the marginal effect of being tall on whether or not I make the shot. That's our Y variable. Here it was negative, here it's positive. So what must exist? What I talked about at the beginning of class, we could calculate a turning point, right? So we must have a turning point because the marginal effect is positive for one of these values and negative for the other. So we could think about, for us, what is that turning point going to be? Well, if I have this marginal effect, if I set it equal to 0, that should be where the turning point is. A little bit of, rearranging this will tell me that that turning point is negative beta 1 over beta 3, or negative whatever the coefficient on my dummy variable was over the coefficient of my interaction. So if I wanted to do this in stata, right, we can actually calculate where that would exist. All right. So here I could do this a couple different ways. I could say display simply negative whatever the coefficient on that dummy variable was, divided by the coefficient on my interaction term. I could also, this isn't like best practice, but I could generate a new variable where it's simply equal to what that turning point is. It'd be the same equation, right? Actually, I think I forgot my negative sign here. Right, so I could use that display command, or I could create a new variable if I wanted to, right? Now I'll do both of these here because I want to kind of show you something. So it tells me the turning point is 24.13, which makes sense because when I calculated the marginal effect at 20 and 32, it switched somewhere in that range. The exact value would be 24.13. Now, if I looked at every player in this data set, if I wanted to, I could create this new variable where I had this turning point, and I could compare that to where the shot distance was and actually see if the player was tall and like back out whether or not there was actually a positive or negative effect. We're not going to do that. It's much more in depth than we need to do, but that is something that we could do, right? And that's why you might want to create that turning point as a new variable. It's just in practice, we probably don't have much use for this in our actual data set. So this isn't probably like best practices. If you're just caring about the value, using that display command should be more than sufficient for what you need.
Will you ever ask us for a point in the same formula to find turning points, so marginal effect that is not 0? So would we ever have to find like the marginal effect at 5 and then do the
like the turning point for where the marginal effect would go from being above 10? Is that what you're asking?
Well, the turning point is when marginal effect equals 0, right?
Mm-hmm.
So what if you were to ask us another, or would you?
Where it's equal to 10?
Yeah.
No, I'll ask you to identify this. Now you really could. All you're doing is starting out with the same equation, but instead of setting it equal to 0, you would set it equal to 10. And you'd use the exact same method. But no, I'll just ask you to kind of calculate where that turning point is. Okay. Any other questions in this example? Okay. Don't really have something here. Oh, let me see. Where are these coefficients? This might be helpful for us. Negative, and that's not going to. So just to give you an idea, the data here, this is once again, we're sometimes finding these data, not to complain about my job, but finding these data sets, right? Sometimes if I want to show something to you, it's hard to find, like, I don't know what the data is until I actually work through all of it. But let's just, for the sake of this example, because I want to make this point, let's say I did calculate this turning point, and let's see, say for whatever whatever the results were, it showed me that the turning point is 104. Well, let's just assume that's what the turning point was. A follow-up question could be, will this exist in the data? Well, that's where I would go back and say, okay, this is the turning point. What? This is where the marginal effect of being tall. This is the shot distance where that marginal effect goes from positive to negative. So for us, it was about 24, right? Also, just one thing that might be helpful, you can always include, like you can use this display command. This is what I try to do when I'm like writing out something to remind myself. This will display the value and state up, but if you want to kind of have it saved for later use, when I was up here and I found that the marginal, that turning point was 24.14 about, you could always kind of add that as a comment of that's kind of what that turning point was. Now the display command will show you the exact value, but if you just want to kind of have a rough estimate, you can always kind of add comments in there, just kind of best practice stuff I'm kind of trying to give you, as some of you have reached out to me about potentially doing an honors thesis or things like that. These are some things that we want to start to try to write our code so that if somebody else uses it, they would kind of be able to pick up what we're doing. So I said, what if the turning point was 104? Well, if I look at that shot distance variable, will that value ever occur in my data set? No, right? Because the highest possible value I could see for shot distance is 86. I'll never see 104. Similar kind of idea. If I, for some reason, had coefficients that had the same sign, I could end up finding a negative turning point. And a lot of times these are easier because they're more obvious. If shot distance is how far away I am from the basket, and I find a negative turning point for the marginal effect, can that ever occur? The closest I can be is 0. It only works in a positive direction. So these ones are sometimes easier to rule out. It's these really high values, right, that might go outside the maximum of our variable, which is a little bit trickier maybe. Any other questions on this before we kind of push it even a little bit further? Okay. All right. So. Oh, I did not want to do this. Hold on. Oh, that's fine. So we thought about kind of marginal effects. So the next thing we're going to do is even more complicated. We're now going to look at not a dummy interaction with a continuous variable. We're going to look at a continuous variable interacted with a continuous variable. Okay. So here things aren't as easy, right? So it's not going to look a whole lot different when we write it out because I've still got each variable I've included. I also am going to include the interaction term. So just kind of to retouch on some things we haven't mentioned today, but we talked about last Thursday. When I include this interaction term, what's definitely going to happen to my R squared? Well, I've essentially added another variable, so it has to go up. What about my adjusted R squared?
Oh, it usually goes down.
I don't really know, right? If the interaction is highly statistically significant, am I going to be able to explain more of the variation in Y? Yes, but I'll be penalized for using an additional variable. So if it is highly statistically significant, that might overshadow the fact that I had to include another variable, and maybe I see the adjusted R squared go up. But I could see it go down. If I add the interaction term and it's not statistically significant, well, then I'm not really explaining any more of the Y variable, and now I'm being penalized for including there. It would be likely I see the adjusted R squared go down. So that statistical significance on the interaction term and what happens to the directional change in my adjusted R squared likely will always be in the same direction. Now, if we're around the cutoff, right, if I had like a p-value of 0.14, that's a little bit harder to know. But if I had a p-value of 0, likely that adjusted R squared is going to go. That was a highly statistically significant variable that I included. It's an interaction of other two variables, but it's essentially like I'm adding a new variable. Right? Now, if I have a p-value of 0.8, the interaction term really was basically useless. So what's going to happen to my adjusted R squared? It's going to go down. I'm going to be penalized for the fact that I just threw in another variable there. Okay. So same kind of thing that we were talking about before, right? It's just now we have two continuous variables. So if I'm thinking about the marginal effect of this x1 variable, it goes back to the same thing. I'm taking a derivative of y. You know, I want the marginal effect of this x1 variable. I take a derivative of y in respect to that variable. So what would I be left with? Beta 1 plus beta 3 times the variable I interacted it with. But when I interact two continuous variables, the marginal effect of each variable will depend on the other variable now, right? If I wanted to find the marginal effect of x2, same thing. If I took a derivative of this equation, I would have what? Beta 2 plus beta 3 times x1. So my marginal effect of each variable will now depend on the other variable it was interacted with. And we were really saying that with the dummy variable, it was just a little bit easier because we had like the marginal effect was only going to be for the 0 and the 1 group. Now the marginal effect, it changes for every single possible value of that other continuous variable. For a dummy variable, the only possible values were 0 and 1. Now we've got a whole range. Okay. So got an example here, and we'll kind of look at some stuff in Stata, just getting a different example or different set of variables. So I had this like happiness data set. I think we've looked at this before. So I had age and hours worked, and I thought about what happens if I interact these two continuous variables. So I've got that as I get older, maybe I'm less cynical. No, a lot of people I meet that are older, this seems to not be the case, but my happiness goes up, right? If I work more hours, I have more money. Maybe I also see there's an increase in this happiness variable. However, there's some interaction between the two and it appears to be negative. So as I get older, if hours of work is higher, the effective age is actually lower. And if I work more hours and I'm older, the marginal effect of working one more hour is also going to be lower. I could think about if I'm going back to these marginal effects, the marginal effect of age, if the interaction term is negative, will be getting lower as the variable is interacted with goes up. And the marginal effect of hours worked, if this interaction coefficient is negative, is also getting lower as my age goes up. So the marginal effect will depend on the other variable that it was interacted with. Okay. So if I use these results, right, I can kind of start to think about, yes, initially when my hours of work is low, in fact, you can always maybe think about if I've interacted age with hours worked, what tells me kind of the baseline marginal effect of age? Well, I know it's going to be a function of the variable I interacted it with, right? So if I wanted to, I could just take this here, replace this with age, replace this with hours worked. It would depend on the other variables. So we'll do that here for a second, just to kind of have this, get some more practices with this. So I can't have this happiness variable. I had the coefficient, I've got age, I've got hours worked, and I have the interaction of the two. Okay. So the marginal effect of age, I took a derivative of this function in respect to age, was beta 1 plus beta 3 times hours worked. And then the marginal effect of hours worked was beta 2 plus beta 3 times age. The marginal effect of each variable depends on the other variable. So how can I think about like the baseline marginal effect of age? That would be when hours worked is equal to 0. So I could almost think about, if I wanted to, for different values of hours worked, graph out what the marginal effect of age was. Where would that marginal effect start out? Well, it would start out at what? Beta 1, if hours worked was equal to 0, because 0 times anything would be 0. And I think here we had a negative coefficient, so I probably should have saved myself room and drawn this up here, because that means as hours worked goes up, what's happening to the marginal effect of age? Well, if beta 3 here we found was negative, the marginal effect must be going down. Okay. So I can kind of think about my baseline effect is when that other variable I interacted it with is equal to 0. If it just kind of helps to kind of think about what we're doing with the marginal effect there. Okay. Now, once again, notice in this example, didn't really draw this very well, but if I had the right sizes, what could happen with the marginal effect? If I think beta 1 we had was positive, it could start out here, and at some point it could become negative. So what do we have? A turning point, right? We basically could say, okay, this marginal effect of age, what is its turning point, right? Now the turning point will be relative to the variable I interacted it with. So what am I going to do to find a turning point? I set the marginal effect equal to 0, rearrange this equation a little bit, and I find that the turning point for hours worked would be equal to the coefficient on the variable I'm looking for the marginal effect of, negative, right? So this is your coefficient on the variable that you're looking at the marginal effect of, and then you're dividing that by kind of that coefficient on the interaction term. So it's going to look very similar to what we were doing before. We had dummy continuous interactions. It's just that now both these variables are continuous, right? But we still are possibly going to have a turning point. And then I could do the exact same thing, but for the marginal effect of hours worked. It might have a turning point in respect to age. So these turning points for the variables we're looking at, that turning point of the marginal effect will always be what is the value of the variable I interacted it with that would cause this marginal effect to go from positive to negative. So if I want the marginal effect of age, its turning point will be the value of hours worked, where the marginal effect becomes positive to negative or vice versa. If I want to find the marginal effect of hours worked, its turning point will depend on values of age. Okay. So we're going back here. Okay. And find those marginal effects, right? I can identify kind of where those coefficients are in my interaction term. So we kind of already talked through this, but very similar thing. I kind of jumped the gun a little bit on the turning point thing, but let's say I had the marginal effect of age being 1 year older. It depends on hours worked. So once again, I can't ask you to tell me the marginal effect for every single possible hours worked, right? Technically, if I could work minutes or seconds, that would take me forever, right? But I could ask you for the marginal effect of being 1 year older or the marginal effect of age at different values of hours worked. So what's the marginal effect of being 1 year older if I'm currently working, say, 30 hours a week? All I would do is take the coefficients for my regression, coefficient on age, plus the coefficient on the interaction term, and then multiply that by the value I'm interested in finding the marginal effect at, right? Hours worked of 30. And then I could do the same thing, but find the marginal effect of age if I was working 60 hours a week. Kind of notice being 1 year older, right? Does that increase or decrease my happiness? Well, being 1 year older, it's increasing my happiness. But if I'm working more, what is that getting closer to? 0, right? Being 1 year older really does not make me happy if I'm working 80 hours a week, right? Being 1 year older, I'm happier if I'm only working 20 hours a week, right? So there will be a point at which this switches over from being positive to negative, right? What that point would be, right? We could kind of find that turning point by using that coefficient of age, ratio to that coefficient on the interaction term. And I'm guessing it's, like I said, I don't know how high it is, probably somewhere around 80. Like if I was just looking at that, what that decrease in the marginal effect was. But I think I'll skip ahead here. I think that's what I have here. Right? So we kind of already talked through this. If I'm using the same example, where does the marginal effect of age actually switch from being positive to negative? Well, here's my marginal effect. I set it equal to 0. I kind of and rearrange it a little bit. I grab that coefficient on age. I grab the coefficient on the interaction term, and I find, sure enough, it's close to 80, but it's at 75 hours a week, right? So in general, being older, I tend to be happier. Unless I'm working more than 75 hours a week, right? Then the marginal effect of being 1 year older starts to become negative. So we can solve for these turning points with continuous interactions, just like we did for this dummy continuous interaction. Yeah.
So could I say that if I'm working 75 hours a week, being younger would be more happier?
Yeah, right. Because we're saying if I'm working over 75 hours a week, I know that the marginal effect of age is negative. So that's the effect of one additional unit increase in X. So being 1 year older, my happiness will go down. So if I'm 1 year younger, my happiness at 75 hours worked would have to go up. We're just kind of working in the opposite direction. Yep. Yeah.
So if we're seeing if turning point like it like meaningfully exists or not, do we compare, like if that's the turning, do we compare that to our data, or do we compare
Yes.
like the theoretical?
So I'd have to give you, right, you would, I don't think I asked you a question like this on the quiz, but in the problem set, I would look at this and say, well, man, 75 hours seems like a lot, right? Is anybody in my data actually working more than 75 hours? How could I check for that? Simply use the sum command. And then if I have people in my data set working more than 75 hours a week, is that a practical turning point? Well, it exists. For some people, that marginal effect would then be negative if I was working, say, 80 hours a week. Right? Any other questions? Yeah, so it really comes down to, if it was like on an exam or something, I'd have to give you an idea about what the range of that other variable that you interacted age with was, right? If I don't have anybody in my data set who works more than 75 hours a week, then no, it's not a practical turning point. I won't ever see it exist. So I know the marginal effect. Let's say nobody works more than 75 hours a week. What's the marginal effect of age always going to be? Positive, right? That turning point, we'll never actually hit it.
Assume we're gonna be interpreting turning points. Is there like significance levels to how many people are within the range, or sorry, how many people the turning point would affect? So what if it's only massive outliers?
Yeah, so I'm not gonna ask you about that or push you that far, but maybe if you took a course after this, you would start to think about like, this turning point exists. Well, honestly, it probably wouldn't be an econ class or a stats class, sorry. It would probably be more like public policy class, right? Because let's say, oh, I don't know. Having more, let's say having more income, I interacted income with, I don't know. It's another good continuous variable that we could look at with happiness. Oh, I don't know. Let's do like income with kids or something like that, right? I might push for different policies if I know the marginal effect of income is going to be positive for 90% of people. Anybody who has kids lower than three or lower, I know that my policy is only going to be impacting like, is going to be positive for like most people. If that marginal effect is only negative of having more income, if I have, or you know, whatever it is, the program we're looking at, if I have more than 4 kids, I know that's only going to impact a very small percent of people. So you would probably be thinking more along those lines, probably if you're a politician, right? Or you're working for the government and trying to think about pushing different policies. Where does that turning point exist? But it's useful to know where the turning point does exist, because now I know if my policy is going to like be impacting a larger group of people versus a smaller group in terms of, is it going to have a positive marginal effect for most people or not? If I'm pushing for something that has a negative effect for most people, is that going to get me elected? No, right? So knowing about like what percent of your data would be impacted, we could very quickly do that, right? We could like create a dummy variable to say, am I working more than this turning point? And then see how many people is this marginal effect actually going to be negative for? And then if it's a very small percentage, this is a good policy to push through. If it's a very large percentage that it would be negative for, I might want to hold, you know, if I'm a politician, I might want to pump the brakes, right? And the same kind of thing would apply to companies, right? If I'm thinking about doing something where it's going to have a negative impact on a vast proportion of individuals, that's not going to be something I want to do. And this could even be from like a PR perspective, right? So yeah, this is maybe off, you know, going off on a tangent a little bit, but this is why we would want to know what those points are. Other questions on this idea? I skipped over this slide. No, I didn't. Where did I go? We skip over it. Oh yeah, here we go. So I could do the same thing, but if I wanted to know the marginal effect of 1 more hour worked, right? So maybe I'm a company and I'm thinking about, do I want to institute some mandatory overtime or something like that, right? Where my workers are going to have to work 1 more hour on average. Well, I would take a derivative of my regression equation in respect to hours worked. I'd be left with beta 2 plus beta 3 times age. So I know that my marginal effect, if this was positive, so I think if we go back, yeah, hours worked coefficient was positive, but the interaction is negative. So the marginal effect of working 1 more hour, when I start out at age of 0, it's going to be positive. But then as that person gets older, that marginal effect is going to be going down. There could be a turning point that exists, right? So I could calculate that marginal effect for different values. So notice here, a 22-year-old, the effect of working 1 more hour, what is that marginal effect going to be on happiness? Well, when I was, 18, 20, but really anything before like 26, having more money in my pocket probably made me a lot happier than a lot of other things, right? So when people are young, what's the marginal effect of working 1 more hour? Well, it sucks to have to work. Well, what brings me a lot of happiness? I've now got beer money, right? And so the marginal effect here for someone who's young really high. I mean, no, I shouldn't say really high, but 0.07. Whereas the older I get, what's the marginal effect? If I'm 60 and you tell me I can work another hour, I don't give a shit. Right? Like I'm tired. I want to go home. The additional money isn't impacting my life that much. That marginal effect is much lower. And eventually, past 60 years old, there's going to be some point where it becomes negative, right? Working one more hour is actually going to have a negative impact on my life because the additional money I'm getting, that's worth less to me than the utility I would get from being able to sit at home on a Friday night and watch, I don't know what old people watch, right? But that's the idea, right? We can pick up what these marginal effects are, and we know just inherent, like these examples I'm using, and like these kind of probably not the most, Kelly probably wouldn't love the way that I'm talking right now, right? But like these are real world examples where we know these interactions exist, right? We know that 22-year-olds view an additional hour worked very differently than a 60-year-old, right? And we want to be able to pick up what those differences are. So once again, we could do a turning point for here. I don't think I threw in the slides. I think I just did. Oh no, I did. There we go. Right, I could find the turning point for the marginal effective hours worked. Looks like it's like an age of 80. Well, this is a good example where, was this practical? I mean, technically it's probably possible, but most data sets, are most people still working when they're 80? No. I mean, is there someone? Probably, right? There's probably people that like to work who might be working who are over 80. So maybe we would see that the marginal effect of an additional hour's work does become negative for people who are older than 80. But if I'm looking at this and I'm thinking about most labor data sets, we don't see people working really, late into their 70s. So this is probably a pretty impractical turning point, right? And if it's not, to your point earlier, how many people would this turning point actually be, how many people will we actually see a negative marginal effect for? Very, very small amount, right? So this is why if I'm the company and I'm pushing for mandatory overtime, if I know the marginal effect is positive basically until my worker turns 80, am I going to want to push for that program? Yeah, because I know that there's almost nobody working for me where that marginal effect will become negative.
So is how far the marginal, or sorry, is how far the turning point out is from, I guess, from the mean, is that commensurate with how big the effects are for each of the individual variables? So for age and for hours worked?
So it has somewhat of a relationship to the mean, but not quite, right? Because I understand your question. It's more in depth than I would ask, but it's a good question, that the idea of like this turning point, my marginal effect, I have a distribution of age, right? And so when I calculate like the mean hours worked, I'm going to have a higher bulk of people that are working around 40 hours than I am 20 and 60 or 7, whatever it is. And so it won't be like a direct just comparison to the mean, but it would be some function of where the mean is, but my distribution isn't guaranteed to be normal. So I can't actually say it's the mean, right? Because it would be the mean if I had a perfectly normal distribution of the other variable, in this case, age, but I don't likely have a perfectly normal distribution for most of my variables. So it'll be somewhat related to the mean, but not perfectly. Does that?
That does, yeah.
I won't push you kind of further to like discuss anything like that, but it is, you're thinking about it the right way. Any other questions on this before we can? Okay, where are we at in time? So I skip over anything else. I think we kind of hit on these. We talked about turning points. We were looking at kind of the marginal effect of both groups. So that should kind of do it for our continuous interactions. So we've got what, 15 minutes left today? Let's do this example since we're using the happiness data set. And I think what we're going to do on Thursday is we'll look at this election data and we'll start to think about nonlinear relationships. So I think the file that I put up there is primarily looking at just like, was initially looking at, oh no, yeah, this is what I want. We're gonna be looking at continuous interactions again. So I'll basically show you a different example, just with a different data set, and we'll kind of revisit a lot of these topics. But I'll do one with this happiness data set just to kind of end this out for today. So next class, I don't think this will take us the entire time. You'll probably see me put up the next like week 12 materials, and we probably will get started on those. If we do take the whole class to talk about interaction, that's kind of what I was expecting anyways, but you might see those materials pop up just to kind of be preemptive in case we do get through things a little bit quicker. I won't put out the next quiz or problem set because the current quiz is due today at the end of the day. The problem set is due by the end of Friday. So after Thursday's class, I'll put up the next practice materials and the next problem set that are related to interaction terms, okay? That due date will be kind of not just next Friday, it'll be a little bit further out on that problem set, and the same thing kind of for the quiz, just to kind of give you a little more time to kind of complete the old problem set and kind of think about reviewing that material first before we kind of move on to now start giving you questions about interaction terms. Okay, so that'll be kind of after Thursday's class. That's kind of where we're going. But for today, we'll look at this happiness data. Let's see. Oh. Let's hope that I put it in the right folder. Fingers crossed. Yes. Okay, good. So I'm now going to think about, I don't have any additional controls here. So we were just talking about the age, hours worked, continuous interaction. Let's think about now kind of doing this for children and hours worked. Okay. So I run this regression. I kind of see, okay, having additional children, right? Looks like it increases happiness, working more increases happiness. The interaction of these two actually looks like it is positive as well. So we're gonna maybe have some results that look a little bit different than the other example because there we had an interaction term that was negative. So if I think about this interaction between children and hours worked, right? Let's do some old stuff. So let's just say, let's look at an example without the interaction term. And then once again, this is just what I like to do. Create my own interaction term that I get to name myself, which is the interaction of children with hours worked. I just kind of shorthand it, makes it a little bit easier to type out. So I'm going to create my own interaction. I'm then going to run this regression with those two variables, except for I forgot my y variable of happiness, and then the interaction of the two. Okay. So if I run the regression without the interaction term, okay, so I've got a lot of observations here, which shouldn't make it more or less likely I can find statistical significance. More observations we have, that distribution gets tighter, same value would actually have a smaller p-value, more likely we can reject. Sure enough, I get really low p-values here. Okay. I probably have a lot of omitted variable bias going on here because I don't have any controls, but just to kind of revisit some of these topics. Now, what's likely going to happen to my R squared when I add in the interaction term? It should go, yep, because it's almost like I'm adding a new variable. Okay. So now my adjusted R squared, let's see, I don't know if I can show this to you without showing it to you. So just to make the point, there we go. Right. So I added the interaction term. I think our previous R squared was 0.015 or 0.0015, whatever it was. That's what our adjusted R squared was. Did I find statistical significance on the interaction term? No. Right. So right away, does that suggest I should be including it or not? If it's not statistically significant, I don't really need it in my model. Now we're going to ignore that for some of the subsequent stuff we'll do. We'll act like it is. But because it's not statistically significant, when I add it in, that penalizes my adjusted R squared because it's like I'm adding in a new variable. I add a new variable that penalizes my adjusted R squared. Am I able to explain really any more of the variation in happiness here with the interaction term? No, it's not even close to statistically significant. So what should be happening to my adjusted R squared? It's likely going to be going down, right? So let's see if that's the case. 0.0014, sure enough, we're out to like the fourth decimal, so it doesn't look like much, but it is going down, right? So this is where that statistical significance of your coefficient, if it is statistically significant, your adjusted R squared likely will be higher. If this was like an exam or something where I maybe put a white box over that and asked you, give a reason why you believe the adjusted R squared will be higher or lower and why, well, I would believe it's probably going to be lower because by adding in my interaction term, I know that penalizes the adjusted R squared, but I wasn't able to explain any more of the variation and why because it's highly statistically insignificant. So I would expect that adjusted R squared to be lower. And then the reverse would be true as well. If it was statistically significant, even though my adjusted R squared is penalized, I can now explain more of the variation. So it'd be more likely my adjusted R squared is higher. And like I said, that won't always be a guarantee, but we can say that it would be more likely or less likely, right, to go up or down. Okay. Anything else I want to say here? So just to kind of make this point, because I don't think we've done this with these continuous variables yet. Let's say I wanted to predict the happiness level or whatever this variable is for someone that has 3 children and is working 55 hours a week. Okay. So how would I do that? Well, go through, I take the coefficient on children, that would get multiplied by 3. I would take the coefficient on hours worked, that would get multiplied by 0.0013. I would then take the coefficient on the interaction term. What would I multiply that by? 55, and then I would multiply it by 3. Right? My interaction term, I'm multiplying these two variables. So I actually would need to plug in the value for both of them. So if the context of our example, if I asked you to make a prediction here, I could use that display command, type. And I would say, take that coefficient on children, multiply it by 3. Add to that the coefficient on hours worked. And I said, what was 55? And then add to that the coefficient on the interaction term, but multiply that by both 55 and by 3. There we go. Now, what's one thing I also forgot here? Easy points if this was like a problem set. What's in every single regression we run? The value of that constant. So I would need to add in that coefficient of the constant as well. So if I go ahead and run this, I get to that predicted value of happiness. However, this was being measured, I don't know what a unit of happiness is, right? How do we measure utility? It was 2.23. Okay. So we can still make predictions using these interaction models. It's just when we have continuous interactions, this part is a little bit different. It's not just one value that we need to multiply that coefficient by, it's actually the value for both variables now. Any questions on that idea?
This is
Yeah.
probably like a bit beyond the scope, but let's say I was wanting to do a regression looking at the interaction with children and hours work and age. Would I want to toss all of that into just like one variable, or would you probably need multiple interaction variables?
So you can do double interactions. You can also do, so I'll explain double interactions first. Because this is a good question. So when I was graphing out the marginal effect of age, I could show this to you that it's changing with different values of hours worked. if I include an interaction of age, hours worked, and children, I now can still find the marginal effect of age, but it will now depend on the values of both variables. Instead of a nice two-dimensional graph, my marginal effect will now be a three-dimensional graph, or I'd have to use like matrix algebra, basically, right? Or linear algebra, like this would be like matrix form. Technically, if I don't want the visualization, I could include quadruple interact. I could septuple interactions if I wanted to. It gets a lot trickier and harder to think about when I start to include interactions with multiple variables. I can run into an issue that we've talked about before, and it's not always as obvious if I don't understand the relationship between those variables, which is imperfect multicollinearity. And it gets, the more you interact, variables you interact with, it's harder to think about what might actually be imperfectly multicollinear. And so then my estimates, if I have imperfect multicollinearity, we said our standard errors are going to be higher. And so then that might not look like these interactions matter when they in fact do, right? Or vice versa. So can do it, but definitely makes all of this even harder. But yeah, a lot of that, and I would say if you're looking at like academic papers, the furthest that you probably would see someone do is like a double interaction, because after that, the results become kind of uninterpretable in terms of the application to real world issues. But yes, you can do it. Okay, so I think what we're gonna do here is end right here, right? So I'm gonna save this so that I have this file, upload this due file after Thursday's class. So I'm kind of making changes to it. Hopefully, if you're working along with me, if you're making some of these as well, you have them. But I will kind of post up this, change due file when we're all kind of complete with this interaction term stuff. We'll continue to work on this example, looking at marginal effects of both variables. Then got that election data. I'll take a look at that as well. I just think seeing more examples, working through more problems with this is going to help. So we'll kind of do that. I'm guessing we will get done doing that prior to the end of Thursday's class, and we'll likely start on the next topic, which is just data issues. That encompasses a lot of different things. Other than that, don't think I have anything else I need to tell you guys. Happening class quiz today. We might expect one later this week. We have one class remaining. So we'll see you guys on Thursday.
I just have a quick question. I have another